picture this. It's 1926, and a 16-year-old kid from Nebraska walks into a Packard dealership carrying a metal contraption made from hardware store parts and water pump fittings. The salesmen laugh him out of the Ryu's showroom. 3 months later, that same kid's Model T is outrunning their $3,500 Twin Six on public roads, embarrassing Packard owners across the Midwest with parts that cost him $12. His name was Ernie Bergstrom, and before anyone in America had heard of superchargers, he'd built one in his father's barn that would change hot rodding forever. The golden age of Packard. To understand why this matters, you need to understand what Packard represented in 1926. These weren't just cars. They were rolling statements of wealth and power. A Packard Twin Six cost more than most people made in 2 years. We're talking $3,500 when a Model T sold for under $300. That's not a price difference. That's a class system on wheels. Packard had been building America's finest automobiles since 1900. By the 20s, they'd perfected the art of making cars that whispered instead of coughed, that glided instead of rattled. The Twin Six engine was a masterpiece of engineering. 12 cylinders, smooth as silk, producing 85 horsepower. That might not sound like much now, but in 1926, it was more power than most people had ever experienced. The Packard owners knew it too. They'd cruise through small towns in their massive automobiles, looking down from their leather seats at the farmers in Model Ts. It was automotive aristocracy, and everyone knew their place. The message was clear. If you couldn't afford a Packard, you couldn't compete with a Packard. Speed, power, prestige, these things belonged to the wealthy. Main Street in any American town had an invisible hierarchy. Packards parked near the bank, Cadillacs near the lawyer's office. Model Ts, those were for everyone else. And everyone else knew better than to challenge their automotive superiors. The technology gap was real. Packard had teams of engineers, advanced manufacturing, decades of refinement. What could some kid with a wrench possibly do about that? Nothing, according to conventional wisdom. The automotive class system was as fixed as any other. You either had the money for real power, or you didn't. There was no third option. Except, nobody told Ernie Bergstrom that. Nebraska, 1925. Ernie Bergstrom was exactly the kind of kid you'd expect to own a Model T, and exactly the kind you wouldn't expect to revolutionize automotive engineering. 16 years old in 1925, living on his father's farm outside McCook, Nebraska. Population 3,000, if you counted generously. The kind of town where everyone knew everyone, and nothing interesting ever happened. His father, Gustav, ran a decent-sized farm and had a small machine shop where he repaired farm equipment. This was crucial. Ernie grew up around lathes, milling machines, welding equipment. While other kids were learning to plow straight rows, Ernie was learning to cut threads and true shafts. He could read mechanical drawings before he could read Shakespeare. The Model T was a 1923 touring car, bought used for $75. It ran, barely, 20 horsepower from its inline-4 engine. Top speed of 45 miles per hour downhill with a tailwind. It was transportation in the most basic sense. It got you from the farm to town. Slowly, loudly, with all the excitement of watching paint dry. But it was Ernie's. His first car, bought with money from helping neighboring farms during harvest. He maintained it himself, knew every bolt, every quirk. The magneto that needed adjustment every 50 miles. The carburetor that ran rich on cold mornings. The transmission bands that slipped when they got hot. It was a relationship, not just ownership. Why would a kid who could barely afford gas think about challenging Packard? Because nobody told him he couldn't. Or, more accurately, nobody told him he couldn't until they did. And by then, it was too late. The obsession had started. The humiliation. It happened on a Saturday afternoon in May 1926. Ernie was heading home from the hardware store, putting along Main Street in his Model T. The speed limit was 25. He was doing maybe 22, which was optimistic for the old Ford. Then came the Packard, a 1926 Twin Six in gleaming black, looking like it cost more than every building on the block. The owner was Chester Ainsworth, who'd made money in real estate speculation and wanted everyone to know it. He pulled up behind Ernie and laid on the horn. Not a polite tap, a sustained blast that said, "Peasant, move." Ernie pulled to the side. Ainsworth roared past, close enough that Ernie felt the wake of displaced air. Then, and this is what did it, Ainsworth leaned out the window and shouted, "Get a real car, farm boy." His friends in the passenger seats laughed. They actually laughed. The technical reality made it worse. The Packard Twin 6 produced 85 horsepower. Ernie's Model T made 20. That's a 4-to-1 power advantage. The Packard weighed nearly twice as much, but could still hit 70 miles per hour. The Model T topped out at 45 on its best day. It wasn't even a contest. It was a category difference. Everyone in town heard about it. Small towns are like that. By Sunday morning, half of McCook knew Chester Ainsworth had shown that Bergstrom kid what real automobiles looked like. People thought it was funny. Ernie's friends ribbed him about it. Even his father suggested maybe he should just ignore rich folks and their fancy cars. But Ernie couldn't ignore it. Not because of ego, though that played a part. Because of the math. He'd seen something in that Packard's acceleration that bothered him. It wasn't magic. It was just more air and fuel entering the cylinders. More mixture, more power, simple physics. If the Packard could make 85 horsepower from 12 cylinders, what if you could force more mixture into 4? The obsession wasn't about beating Chester Ainsworth. It was about solving a problem everyone said was unsolvable. Making power without money, speed without status. That's what kept Ernie up at night, sketching in notebooks, thinking about air and pressure and the fundamental relationship between them. The aviation connection. Here's where Ernie had an advantage nobody expected. His uncle, Carl Bergstrom, had been a military mechanic during World War I. Not a pilot, but one of the guys who kept the planes flying. Carl had returned to Nebraska with stories and, more importantly, with technical knowledge most people didn't have access to. The Germans had been supercharging their aircraft engines since 1915. Mercedes built the first successful supercharged airplane engine, and it gave German fighters a critical advantage at high altitude, where air got thin. The concept was simple. Use a pump to force more air into the engine than atmospheric pressure would naturally provide. More air meant more fuel. More fuel meant more power. Carl had worked on some captured German engines. He'd seen the superchargers up close, understood the principles. One evening in late May, Ernie asked him about it. Carl explained how it worked. A compressor driven by the engine itself, spinning at high speed, packing more air molecules into each cylinder stroke. It was like breathing normally versus taking a deep breath and holding it. More oxygen, more potential energy. Why wasn't anyone doing this for cars? Cost? Mostly. Complexity? Too. Superchargers for aircraft engines were precision-made pieces of equipment. They cost hundreds of dollars. They required careful engineering, special materials, expert installation. The automotive industry knew about supercharging, but considered it impractical for consumer vehicles. Too expensive, too complicated, too much liability if something went wrong. Ernie listened to all this and thought, what if it doesn't have to be complicated? What if you could build something simple that just moved air? It wouldn't be efficient, it wouldn't be pretty, but would it work? He started reading everything he could find. The McCook library had exactly 3 books that mentioned forced induction. One was about steam engines, one about industrial pumps, one was a technical manual Carl had somehow acquired. Ernie read them all multiple times, taking notes, sketching concepts. The theoretical knowledge was there. Aircraft superchargers used centrifugal compressors, spinning impellers that flung air outward to increase pressure. You needed a housing, an impeller, a drive mechanism, and a way to feed the compressed air to the carburetor. That was it. 4 basic components. How hard could it be? Very hard, it turned out. But Ernie didn't know that yet, which was probably for the best. The hardware store engineering, the beauty of Ernie's approach was his complete ignorance of how impossible it was supposed to be. He looked at a supercharger as a simple pump that moved air instead of water, and McCook had a hardware store that sold water pumps. The core component was an industrial water pump impeller designed for farm irrigation. Cast iron, 6 inches in diameter, with curved vanes that would move air just like they moved water. Cost, $3.50. Ernie bought it in June 1926, telling the store owner he needed it for a project. The owner assumed it was farm-related and didn't ask questions. The housing came from sheet metal and a discarded air compressor cylinder. Ernie welded on pipe fittings for the inlet and outlet. For the drive mechanism, here's where it got clever. The Model T had an exposed flywheel. Ernie fabricated a bracket that held the supercharger just below it and machined a small wheel that friction drove against the flywheel's edge. Crude? Absolutely. But it worked. The speed ratio was 1:3. At full throttle, 1800 RPM, the Supercharger would hit 5400, half the speed of proper superchargers, but Ernie hoped it would be enough. He connected it to the carburetor using rubber hose from a tire inner tube and a sheet metal box. The first attempt in late June was catastrophic. The friction wheel slipped, the hose melted, the carburetor flooded, the engine died. Second attempt, early July. Better, but it blew all the intake gaskets from positive pressure. Third attempt, mid-July with heavier gaskets. It ran. The breakthrough came July 22nd, 1926. Half a mile from the farm, Ernie mashed the throttle. The Supercharger whined. The friction wheel screamed. The Model T took off like someone had kicked it. 55 miles per hour, 10 miles per hour faster than it had ever gone. It worked. A $12 Supercharger had just added 15 horsepower to a Model T. Enough to change everything. Technical deep dive. Let's talk about why Ernie's ridiculous contraption actually functioned. The physics were sound, even if the execution was agricultural. A supercharger increases power by increasing air density in the cylinders. More air means more oxygen. More oxygen means more fuel. More fuel means more power. Ernie's water pump impeller, spinning at 5400 RPM at full throttle, created 3 to 4 psi of boost. That doesn't sound like much. Modern superchargers run 8 to 15 psi. But on an engine operating at atmospheric pressure, 14.7 psi, 3 extra psi represented a 20% increase in air mass. 20% more air meant roughly 20% more power. The carburetor modifications were critical. Ernie drilled out the main jet from 0.062 inches to 0.075 inches, increasing fuel flow by 30%, too rich at idle but perfect under boost. The engine ran rough at low throttle, screamed under load. The accidental innovations were where it gets interesting. The friction drive, chosen purely because Ernie couldn't afford gears, actually worked better than a fixed ratio would have. As RPM increased, the friction wheel would slip slightly, preventing overspeeding. It was automatic boost control before anyone knew such a thing was needed. The total parts cost was $11.80, $3.50 for the impeller, $2 for pipe fittings, $1.50 for sheet metal, 90 cents for a junkyard bicycle bearing. A proper supercharger would have cost at least $200. Ernie achieved forced induction for 6% of what it should have cost. That's not just frugal engineering, that's revolutionary. The efficiency was terrible, 5 horsepower lost just driving the supercharger. But when you're starting with 20 horsepower and adding 15, losing 5 is acceptable. The net gain was still 50% more power. Modern engineers would have 100 criticisms. No intercooler, no bypass valve, terrible aerodynamics, massive parasitic losses. All true, all irrelevant, because it worked, and that was the point. The first test. After the successful drive on July 22nd, Ernie spent the next 2 weeks testing and refining. He wanted to make sure this thing wouldn't explode before he showed anyone. The Model T had never been built for this kind of power, and he needed to ensure everything would hold together. The first concern was the transmission. The Model T's planetary transmission was notoriously fragile. Ernie adjusted the bands tighter than spec and replaced the worn friction material. He also learned to be gentle with the throttle in low gear. In high gear, though, he could hammer it without slipping. The engine internals seemed fine. The connecting rods, which he'd worried about, showed no signs of stress. The crankshaft bearings weren't any noisier than before. The pistons and rings seemed happy with the extra pressure. The Model T engine, while underpowered, was actually quite robust. It had been designed for abuse by farmers who knew nothing about maintenance. The real testing came in early August. Ernie would drive out to empty country roads and run full throttle pulls. The little Ford would accelerate harder than it had any right to. Where it used to take 20 seconds to reach 40 miles per hour, it now did it in 12. The top speed increased from 45 to about 57. Not earth-shattering, but legitimate performance improvement. He tested hill climbing, which was the most dramatic difference. There was a steep grade about 5 miles from the farm that the Model T had always struggled with. Before the Supercharger, Ernie had to run it in low gear, barely crawling up at 10 miles per hour. With the Supercharger, he could climb it in high gear at 35. The difference was night and day. Fuel economy predictably suffered. The Model T had gotten about 25 miles per gallon. With the Supercharger and the enlarged carburetor jet, it dropped to about 18. But Ernie wasn't building this for economy. He was building it to prove a point. The sound was distinctive. The whine of the Supercharger impeller, combined with the screech of the friction wheel and the louder exhaust note from the increased power, created a unique and unmistakable signature. You could hear Ernie's Model T coming from half a mile away. It sounded like someone had crossed a farm tractor with a Banshee. Adjustments continued. Ernie added a crude throttle stop to prevent over-revving. He fabricated a small oil cup that dripped lubricant onto the friction wheel to reduce wear. He welded reinforcements to the Supercharger bracket. Every test revealed something that could be improved. By mid-August 1926, the setup was as reliable as it was going to get. Ernie had logged over 200 miles of testing without major failures. The friction wheel needed replacing every 50 miles or so, but he could machine new ones in an hour. Everything else held. It was time to see what other people thought. Specifically, it was time to see what Chester Ainsworth thought. The rematch. Finding Ainsworth wasn't hard. Rich people have patterns. Every Saturday morning, he drove his Packard to the McCook Country Club for golf. The route took him down a straight 2-mile section of county road, perfect for what Ernie had in mind. Saturday, August 21st, 1926. Ernie positioned himself at the start of that straight section. Engine running, Supercharger whining. He waited, and here came the Packard, black as a judge's robe, gleaming in the morning sun. Ernie pulled onto the road ahead of Ainsworth, close enough to be noticed, close enough to be, once again, in the way. 25 miles per hour. The Packard's horn blared, same as before. But this time, Ernie accelerated. 30, 35, 40. The Packard accelerated too, expecting to blow past the little Ford. 45, 50. The Model T was screaming now, the Supercharger wail audible over everything. Ernie glanced in his mirror. The Packard was keeping pace but not gaining. Ainsworth's face was visible, confusion replacing the usual smirk. 55. The Model T's absolute limit. The speedometer needle vibrating at the top of its range, the whole car shaking, and the Packard wasn't pulling ahead. The Twin Six had more power, but it also weighed twice as much. On this straight road, Ernie's power to weight advantage was enough. They stayed even for nearly a mile. Then Ernie lifted off, downshifted, and turned onto the farm road. The Packard roared past. But this time, nobody was laughing. Word spread fast. By Sunday, the story was all over McCook. That Bergstrom kid's Model T had run with Chester Ainsworth's Packard. Ainsworth found Ernie at the hardware store the following Tuesday. "What did you do to that Ford?" Added some air. "What's that noise it makes?" "Supercharger. Built one, mostly from parts I bought here." Ainsworth stared at him, then laughed. Not mockingly, with genuine surprise. "How much did it cost?" $12, give or take. You're either a genius or an idiot. Probably both. A 16-year-old farm kid had built something Detroit's engineers wouldn't attempt for another decade, using hardware store parts, for $12. Word spreads. By September, Ernie had requests from 3 other Model T owners who wanted Superchargers. He built the first one in a weekend, charged $25 for parts and labor. The customer was thrilled. Suddenly, his Model T could keep up with the newer Model A Fords. Ernie had refined his process. 4 hours for the housing, 2 hours for the friction drive, 3 hours installation. Total time investment, 10 hours for $25. Not bad for a 16-year-old. The McCook Gazette ran a story in late September. Local youth builds performance parts for Ford automobiles. Short, buried on page 6. But it existed. Ernie kept the clipping for the rest of his life. First time his name appeared in print for something other than high school sports. More orders came. By November, Ernie had built 8 Superchargers. Word was spreading beyond McCook. Farmers from neighboring towns would drive their Model Ts to the Bergstrom farm, drop them off, pick them up 2 days later, transformed. The price stayed at $25. Ernie was making $15 profit per unit after materials. The Ford dealership viewed Ernie with suspicion. He wasn't certified, wasn't trained, wasn't doing things the Ford way. But he wasn't their problem. He was modifying cars after sale, which was legally fine. And his customers were happy. The Packard dealership in North Platte heard about it through the Automotive grapevine. They found it amusing. A farm kid making Model Ts faster, cute, irrelevant. Packards were still superior in every meaningful way, but they were missing the point. Ernie wasn't trying to make Model Ts into Packards. He was democratizing performance. For $25, any working person could have more power. That was revolutionary. By Christmas 1926, Ernie had built 14 Superchargers. The most interesting customer drove 8 hours from Kansas to get one. The drive took all day because Model Ts weren't fast. He stayed overnight, let Ernie install the Supercharger, and drove home in half the time. He later wrote saying the Supercharger had paid for itself in time saved. Detroit's reaction. Here's where it gets interesting. Detroit knew. Maybe not immediately, but by early 1927, word had filtered up to the automotive manufacturers that some farm kid in Nebraska was supercharging Model Ts with hardware store parts, and they didn't know what to do about it. Internal Ford memos from 1927, released decades later, show they were aware of aftermarket forced induction modifications in rural areas. They considered it a curiosity. Henry Ford himself reportedly dismissed it as impractical, too complex for average owners, and likely to cause reliability issues. He wasn't entirely wrong, but he missed the bigger picture. Packard's response was telling. They didn't respond. At all. No official statement, no internal investigation, nothing. To acknowledge that a kid with plumbing parts could make a Model T competitive with their entry-level cars would be to admit their entire value proposition was vulnerable. Better to ignore it and hope it went away. Chevrolet, trying to compete with Ford in the low-price market, reportedly sent someone to Nebraska to investigate. That person visited Ernie in March 1927, looked at the Supercharger, took some notes, and left. Nothing came of it. The official line was that forced induction was too expensive for mass production. The real reason? Admitting an amateur had beaten them to it would be embarrassing. The automotive press, what little covered aftermarket parts in 1927, never mentioned Ernie's work. Not because they didn't know about it, but because it didn't fit their narrative. The automotive industry in the 20s was about refinement, luxury, advancement. A farm kid with homemade parts didn't fit. It implied the manufacturers weren't doing enough, weren't innovative enough. Better to ignore it. This reaction, or lack thereof, tells you everything about industrial inertia. Detroit had the resources, the knowledge, the engineering talent to develop superchargers for consumer cars. They chose not to. Too risky, too expensive, too different. When an outsider proved it could be done cheaply and simply, they dismissed him rather than learn from him. The irony is that forced induction would eventually become standard. Turbochargers, superchargers, every modern performance car uses them. But in 1927, when a teenager showed it was possible with $12 in a hardware store, the industry said no, not because it wouldn't work, because they hadn't thought of it first. The technical legacy. What Ernie created wasn't just a one-off curiosity. The principles he demonstrated influenced the hot rod community for decades. Word spread through informal networks. Farmers talked to farmers. Mechanics talked to mechanics. By the early 30s, homemade superchargers were appearing across the Midwest, all descendants of Ernie's original design. The friction drive, which seemed crude, was actually brilliant. It was simple, easily adjusted, and acted as an automatic safety mechanism. When engineers eventually designed commercial superchargers, they had to add expensive clutch mechanisms to achieve what Ernie's friction wheel did naturally. Simplicity won. The sheet metal housing demonstrated that you didn't need precision casting. As long as the basic shape was correct, the impeller would move air. This principle influenced early hot rodders who fabricated their own induction systems. Sheet metal, welding, and basic machining were enough. You didn't need a foundry. Ernie's carburetor modifications showed that fuel delivery could be adapted with simple changes. Drill a bigger jet, adjust the mixture, done. Later, hot rodders would get more sophisticated, but the basic approach remained the same. Work with what you have, make minimal changes, achieve maximum results. Compared to commercial superchargers that would eventually appear, Ernie's design was primitive, but it proved the concept. By the mid-30s, companies like Schwitzer Cummins were selling centrifugal superchargers for automotive use. They cost hundreds of dollars and required professional installation. But the underlying principle, forcing more air into the engine with a spinning impeller, was exactly what Ernie had done with a water pump. The efficiency difference was significant. Commercial superchargers achieved 60 to 70% efficiency. Ernie's design was probably 30% at best. But he started with such low power that even inefficient forced induction made a dramatic difference. Sometimes, good enough is revolutionary. What he got right that others missed was the simplicity advantage. Detroit engineers overthought supercharging. They worried about efficiency, durability, warranty implications, production costs. Ernie just built something that worked. When you're not constrained by corporate requirements, you can take risks. And sometimes those risks pay off in ways conventional development never would. What happened to Ernie? Ernie Bergstrom graduated high school in 1928. He'd built 23 superchargers by then, mostly for Model Ts, but a few for other cars. The business was never more than a side project. He helped on the farm, worked part-time at his father's machine shop, and built superchargers when people asked. He never filed patents, partly because he didn't know how, partly because patent lawyers cost money he didn't have, but also because he didn't see the point. The design was simple enough that anyone with basic metalworking skills could replicate it. A patent wouldn't protect anything. In 1930, at 20 years old, Ernie moved to Omaha to work for Union Pacific Railroad as a machinist. Good pay, steady work, benefits. He occasionally built superchargers on weekends for extra money, but the demand had declined. Model A Fords were faster than Model Ts, and supercharging them was more complex. Plus, the Depression was hitting, and people had less money for performance modifications. He served in the Army during World War II as a maintenance supervisor, keeping vehicles running in North Africa and Italy. The skills he'd learned building superchargers translated well to military equipment repair. He could fabricate parts from nothing, improvise solutions, keep things running that should have died. The Army loved him. After the war, Ernie returned to Omaha and worked for Union Pacific until retirement in 1971. He never worked in the automotive industry professionally. His contribution to hot rodding remained an obscure footnote, known to a few old-timers but largely forgotten. The original supercharger, the first one built in July 1926, stayed on Ernie's Model T until 1933. He eventually sold the car to buy a used Chevrolet. The buyer removed the supercharger, finding it too loud and too thirsty. What happened to it after that is unknown. Lost to history, probably scrapped during a metal drive in World War II. Ernie passed away in 1994 at age 84. His obituary in the Omaha World Herald mentioned his long career with Union Pacific, his military service, and his surviving family. It didn't mention the supercharger. Nobody remembered, or if they did, they didn't think it was important enough to include. But here's the thing. The barn where Ernie built that first supercharger still stands on what was the Bergstrom farm outside McCook. It's someone else's property now, used for storing hay. But if you know the story, if you stand in that barn and imagine a 16-year-old kid with a water pump impeller and a crazy idea, you can almost hear the whine of the supercharger and the screech of the friction wheel. The place where plumbing parts beat Packard, the broader impact. Ernie's story represents something fundamental about American innovation. He didn't invent supercharging. Mercedes had done it a decade earlier. He didn't build the most efficient or powerful or sophisticated forced induction system. Commercial units would surpass his design easily. What he did was prove that high technology didn't require high budgets. This lesson resonates through automotive history. Every garage-built hot rod, every shade tree performance modification, every amateur engineer who's made their car faster on a budget, they're all following Ernie's example. Innovation doesn't belong to corporations. It belongs to whoever's willing to try. The democratization of performance that Ernie pioneered became the foundation of hot rodding culture. The idea that you could take a cheap car and make it fast through cleverness rather than cash, that knowledge mattered more than money. That simple solutions often beat complex ones. This philosophy built an entire industry. Consider the parallels to today. We talk about disruption, about startups beating established companies, about garage entrepreneurs changing industries. Ernie was doing that in 1926, with plumbing parts, against Packard. The technology changes, but the pattern remains the same. Outsiders, with nothing to lose, often beat insiders with everything to protect. The corporate blindness that Detroit displayed, ignoring Ernie's work because it didn't fit their business model, is a timeless problem. How many innovations are dismissed because they challenge established interests? How many good ideas die because they threaten existing revenue streams? Ernie's Supercharger should have been a wake-up call. Instead, it was ignored until it was too late. What does a 16-year-old farm kid teach us nearly a century later? That the impossible is often just the untried. That expensive solutions hide simple alternatives. Ernie didn't know superchargers were supposed to be complex, so he built one that was simple and cheap. The lesson isn't about superchargers, it's about questioning assumptions. Packard assumed their cars were untouchable. Detroit assumed forced induction was too complex. Everyone assumed a farm kid couldn't compete with engineers. Ernie proved them wrong with $12. The plumbing parts weren't special. Mass-produced impeller, standard sheet metal, off-the-shelf fittings. Innovation isn't inventing new things, it's seeing new uses for existing things. Today, every time someone makes their car faster with creativity instead of cash, they're following Ernie's path. Every time a home mechanic outperforms a dealership, they're proving Ernie was right. Remember the farm kid from Nebraska. Remember that plumbing parts outran Packard. Remember that innovation belongs to whoever's brave enough to try. Sometimes that's enough to start a revolution, one homemade supercharger at a time.